We're going to solve a quadratic equation by using what's called the square root property. So to do that, we need to factor this quadratic. That means what two numbers multiplied to give me 9 and add up to 6. Well, those numbers is the exact same number, which is 3, because 3 times 3 is 9, and 3 plus 3 equals 6. Since it's the same, I'm going to write it as a square. Now, once I have it as a square, I can use this what's called the square root property to get rid of this square. So I'm going to take the square root of both sides, and when you take the square root, you always do a plus minus. And so I get rid of the square root, or the square on the left-hand side, because the square root gets rid of the square. Then I have a plus minus, and since 36 is a perfect square, we get 6. So now I can minus the 3 to get my x by myself. So I get a 6 minus 3, because it's a positive 6, which equals 3. And then I also have a negative 6 minus 3, which equals a negative 9. So I have two answers. So I need to take these two answers and plug them back into the equation and see if they work, because sometimes they don't. So I'm going to put my 3 squared plus 6 times 3 plus 9 and see if that equals 36. And that's 9 plus 18 plus 9 equals 36. So the 3 checks out. Then I'm going to do the 9. So I'm going to go 9 squared plus 6 times 9 plus 9. And when I do that math, oh, it's my fault, a negative 9, that's a negative 9. So when I plug in a negative 9 and I square it, I do get 81. But 6 times a negative 9 is a negative 54. And when I add 9 to that, I do get 36. So it also checks. So those two are the solutions. All right, so let's look at our problem over here. We have the same type of problem. I want a quadratic, so I can factor it. So x is not x plus, it's actually an x minus 5, because x minus 5 squared will give us the 27, because negative 5 times negative 5 is a positive 25. So this is an x minus 5 squared equals 27. And I can use the square root property, which would be a plus minus, to give me, to get rid of the square. The difference now is 27 doesn't have a perfect square. So I'm going to add 5. And this is what's called an irrational number, because this number doesn't simplify completely, but it does simplify. And it does simplify to, and I'm going to put the 5 plus minus, and I'm going to simplify that, which is 3 radical 3. So our answer is a 5 plus minus 3 radical 3, and there's my answer. Okay, now we're going to do a process called completing the square. So if you don't have a perfect square to make into, like we've done in the last problems, we're going to create that. So let's look at our first example here. So the first thing we want to do is we have x squared plus 16, saying we want to complete the square. So there's 3 steps. First step is you take half of that b. So there's 16, you take half of it, you get 8. Once you hit that number, then the second thing you're going to do is square that number, which is 64, and that then completes our square. So let's look at a problem right here. If I have x squared minus 14x, I'm going to complete the square. So I take my middle term, 14, take it in half, which is 7, and then I'm going to take 7 and square it, which is 49. And so completing the square of x squared minus 14x is plus 49. And so that's completing the square. So let's use this to solve an equation. So if we have an equation where we don't have a perfect square, 11's not a perfect square, I can move the 11 over, move this over, and create an equation called x squared plus 10x. And I'm going to leave a blank equals, and when I move it over, it becomes a positive 11. I'm going to complete the square now. So to complete the square, I'm going to take half of the b, which is 5. I'm going to square it, which is 25, and that's the number I'm going to put in the spot, so it's a plus 25. Now, if I add 25 on the left-hand side, I have to do the same thing on the right-hand side. So whatever I write on the left, I have to write on the right. Now, this part, when factored, is the square. And when I add that, I get 36. So now I can go through the same process we did on the previous slide. I'm going to use the square root property, square root plus minus. And that gives me the x plus 5 equals, and this happens to be 6. So now I can minus the 5, minus 5. So I have 6 minus 5, which is 1, and negative 6 minus 5 is a negative 11. And so there are my two answers to the problem after I've completed the square. So now let's look at two different types of problems where we're completing the square. And here's one where the first number is a 1 or 2. Well, we always have to have a 1 in the first number. So to get the 1, we're going to have to divide everything by 2 to get this to 1. So if I divide this by 2, and this by 2, this by 2, and this by 2, that gives me x squared minus 7. And I'm going to leave it as a fraction. And I'm going to leave this as a fraction. And 0 by 2 is 0. Now we're going to follow the same process that we've been doing. Is I'm going to minus the 5 halves over so I can complete my square. So I have x squared minus 7 halves equals, I'm going to leave a blank, and I'm going to minus the 5 halves over to the other side, and I'm going to leave a blank for whatever I'm going to add, because I'm going to add something. So I have to figure that out. So that something is taking the middle term, 7 halves, divide by 2. You divide by 2, you're going to get 7/4. Then we're going to square that, which ends up with 49 over 16. So I'm going to put 49 over 16 here, 49 over 16. And then I'm going to write this as a perfect square, which is going to be 7 squared. And if we do the math over here, I will get 9/16, and you can do that in your calculator. Just press this into your calculator and you get 9/16. And now I'm going to take my square root, plus minus square root, and that'll leave me with just my part inside. And this becomes plus minus 3 over 4. Do that in your calculator. So now I'm going to add 7/4 to both sides. Add 7/4. So x equals 3/4 plus 7/4. And it also equals a negative 3/4 plus 7/4. And if you do the math, this one will be 4/4, which is really 1. And this one will be 10/4, which is really 5 halves. And so there's my two answers for this problem. All right, let's look at the next one where we get answers that are a little imaginary. So we're going to do the same. So I'm going to take my x squared plus 8x. And I'm going to move the 22 over, so I'm going to make it a negative 22. And obviously I'm going to be adding something. This is our completing the square, so let's go through the process again. Take my middle term, 8. I'm going to cut it in half, which is 4. I'm going to square that, which is 16. I'm going to add 16 to both sides. And so this will become x plus 4 squared, because that's the factoring. And if I do the math over here, I'm going to get a negative 6. So now I'm going to take the square root of both of these sides, plus minus. So I'm going to have x plus 4 equals plus minus square root of negative 6. Now, we have a negative inside of radical sign, which we've learned previously. That needs to come out as an I. But I'm going to have my x will equal the minus 4 plus or minus. I'm going to bring the I out, square root of 6. And there is my imaginary solutions to a problem by using completing the square.